Hello guys, I'm going to tell you how to solve this question from Aviation Exam Database. This is a general navigation subject and topic flight computer. I found this question interesting for me because there are a lot of comments, and actually after I've done ATPL this subject I've done about half a year ago, so for me it's interesting to refresh my knowledge. So we have questions. We have question. Here is the number, and on this question we've done with track, which is magnetic, heading, which is magnetic either, variation, true airspeed, and aircraft um, speed, ground speed. We must calculate ground speed, and in the end we need to calculate wind velocity and give the answer in true. Okay, let's do it. First of all, for solving wind correction tasks, we need four things. First of all, track. Second, heading. True airspeed and ground speed. For solving ground speed, it's basic math. We just need to understand that during 12 minutes aircraft flies 50 nautical miles. So during 1 hour it will fly much more than 50 nautical miles. If in 1 hour 60 minutes, so if we divide 60 minutes to 12, we have 5 part of 1 hour, and if we multiply 5 to 50 nautical mile, we will have 25. Okay, I will mm, do it this way. Mm, 12 minutes, it's 1.5 of 1 hour, and 50 nautical mile multiply 5, we have 25 knots. But this is not a good method of solving those kind of questions, because there are a lot of questions like this, and we need a calculator. This is a good idea to buy calculator before exams. We can use it, and if you forget your own calculator, you have uh, spare calculator on exam room. So I used the Casio calculator, and here is the model. So it can just multiply 50 nautical mile, multiply 0 hour, and 12 minutes. Unfortunately, I cannot show you how to do it with this calculator. Maybe next time. You know, guys, one thing is to solve question, another to make a video. Okay, anyway, if you had this calculator, you would understand me how to use these minutes. Oh, sorry, guys, divide it. So there is a question. 250. No, okay, this is our ground speed. So just put in mind that our ground speed is 250 knots. So Here is a tool. First of all, this red dot, it shows us true airspeed. Always don't overthink this, it's just true airspeed. Here is 220, here is 230, so each line means 2 nautical miles. We have 225 nautical miles in true airspeed, you see just here. Okay, next step, we need to put heading here, heading, um, always heading, always, because heading is our final solving. So we have true and heading, and for this task we need to put here heading 301 magnetic. Forget about true and magnetic, just our heading uh, 301 degrees. Okay, we have crabbing uh, difference, 14 degrees crabbing. So just think, if our heading is like this, 301 degrees, but our track is 315 degrees. So let's imagine we are flying in this way, and in this way we are flying in this, we are flying with this heading, but we are flying with this way. So the wind blowing from here. And don't forget, wind is always um, shown with a uh, three triangle, track with two triangle, and uh, heading with one triangle. So okay, the we have wind from this direction. Actually, it could be from this direction. It could be, but let's think why, which direction we will choose, this one or this one. We have headwind or tailwind. If we have true speed 225 knots, but ground speed is 250 knots, so you see it's just over there. So we are flying faster over ground, because because wind blowing from tail, and it just blowing us faster than we are flying actually. So actually we need 14. It's somewhere here. Yeah, so this question is not possible to solve this task, because we need the opposite. But anyway, it's somewhere here. You see 10, 15, and here is let's imagine here is 15 degrees, and here is 250 knots. Okay, now we need to calculate the wind. First of all, for this purpose, we need to put this cross just on the bottom of the site, and put this red dot on uh, on some particular value, just to be just for us to make it more easier to calculate. So we see the wind is blowing from 1904, 1904, or maybe 1905. I think 1904 is well, okay, 1905 degrees. This is magnetic wind, don't forget about it. And the velocity is 1 2 3 4 5 6 6 and a bit more. Okay, let's imagine here is about 64 64 knots, 64 knots, and the magnetic is 195 degrees magnetic. Okay, there is our uh, wind. Okay, now we need to change magnetic to true, true uh, wind velocity. So for this changing, as I've already mentioned earlier in previous video, in the explanation, this table worth to be printed out and put just in front of you on your desk. So we have magnetic, we need to do true. So we need to add some value, but don't forget we have 5 west. West means minus. Here is information. West minus. Why minus? Because if true is north, if we have variation to the east, just imagine the needle of our compass just deviate to the right. If we have deviation to the west, the needle of our needle deviating to the left. This must be remembered. If west, there is minus. If east, there is plus. So we have 1905 magnetic, 1905 magnetic plus minus 5. We have here is the number, here is the answer. Okay, let's check it out if it is correct. You see the most the closest one is here. Just let's check if it's correct. Yeah, it's correct. Thank you for watching.